All right, so here's an interesting problem. We have two angles, alpha and beta, but we don't know what alpha and beta are. What we're given is the sine of alpha and told that it's in the first quadrant. And we're given the sine of beta and we're told that this one lies in the second quadrant. All right, so we don't actually know the actual angles, right? So we're just given the sine and cosine. Now we're asked to find the cosine of alpha plus beta. Okay, so let's use the sum formula for cosine. So that tells us that that's equal to the cosine of alpha, cosine of beta, right, times the cosine of beta, minus the sine of alpha times the sine of beta. Okay. Now we have the sine. We have the sine of alpha, right? We have this. We know that this is equal to 3/5. Okay. We also have the sine of beta, right? Which is 5/13. What we don't know is the cosine of alpha and the cosine of beta. But we can figure that out. Now, there's a couple different ways you can figure that out. You could draw the triangle in the unit circle and figure it out, or you could use the fact that sine squared of theta plus the cosine squared of theta is equal to 1. Okay, so let's just use that. Okay, so in this case, the sine of alpha, if we substitute alpha instead of theta, the sine of alpha is 3/5, so the square of that is 9/25, right? Plus the cosine squared of alpha is equal to 1. So the cosine squared of alpha is equal to 25/25. Right? I'm just going to rewrite 1 minus 9/25. Okay, and that gives us 16/25. And then I have to take the square root of both sides. So the cosine of alpha is equal to 4/5. Now it's either going to be positive or negative 4/5, and we can decide that by what quadrant we're in. Now alpha, we're told, is in quadrant 1, so it's positive. Okay, so now we know the cosine of alpha, so I can substitute that in here. Okay, and we also need the cosine of beta, so let's figure that out. So again, I can look at, I know the sine of beta, right? So that's so the sine squared, which will be 25/169, plus the cosine of beta is equal to 1. All right. So the cosine squared of beta is equal to 1. So then the cosine squared of beta is equal to, I'm going to write this as 169/169. Oops. 169. That's 1, and then I'm going to subtract 25 169s from both sides. So 25/169. So that gives me 144/169. Okay, so that's my cosine squared of beta. And I take the square root of both sides to get cosine of beta. And it's going to be 12/13. But again, it could be either positive or negative 12/13 now. So I'm going to have to look at what quadrant I'm in. I'm in quadrant 2. It says beta is in quadrant 2. Right? So quadrant 2, that's over here. This is quadrant 2, where the x coordinate is negative and the y coordinate is positive. So cosine is my x coordinate, so it's going to be a negative 12/13. All right, so I can substitute that in, negative 12/13. Right? And now it's just arithmetic. It's just arithmetic. Working with fractions is not always that fun. But let's see, what do we get? We get minus 48/65. And over here, we're going to have a minus 15/65. Okay. Then I'm going to combine those, and I get a negative 63/65. Okay. So that's my answer right there. And I want to probably circle it because I got a lot of numbers on this page, but that is my final answer right there. The cosine of alpha plus beta is a negative 63 over 65. All right, well, that's all I have for the examples in this particular lecture. Now we're going to cover 2 of them today. So, but you're ready to take a look at the discussion questions, and I'll meet you in class.